Okay, welcome back. This is going to be over lesson 4.4, which is ratios and pi. And this one is a required assignment, so you will have to do this section. And the guided practice will be the DIY. So on this first part, the explore activity, it talks about what is radius, what is diameter, what is circumference. Those should be pretty familiar to you at this point. You've covered circles before. But what you have to do is you have to use a measuring tape to find the circumference of 5 circular objects. I will have some objects on the table. Choose the ones that you want. So you're going to measure the distance across and then to find its diameter and then record it. So you're going to have your object here, what the circumference is when you measured it, what the diameter is, and then you're actually going to divide the circumference divided by diameter for all 5 objects. So remember, look right here, it says round your answer to the nearest hundredth. That is key because some of these are going to come out to some crazy numbers. I would also measure in something simple, maybe like millimeters. That way you can get a pretty accurate answer. So it says, describe what you notice about the ratio circumference divided by diameter in your table. So you need to look at your table. What answers did you get whenever you actually did the explore activity? And what did you notice about all of these numbers over here when you did the division? Okay? So I can't do that because what I choose may be different from what you choose. And if I sit here and do all of these, our video is going to be crazy long. Alright. On the back. It says determining proportionality in circles. The ratio of the circumference to the diameter of any circle is the same as all circles. This ratio, circumference divided by diameter, is represented by the Greek letter pi, called pi. As you calculated the explore activity, the value of pi is close to 3. You can approximate pi as 3.14 or 22.7. Sometimes we're working with fractions, the fraction works out better. Sometimes we're working with whole numbers and decimals, so the decimal number will work better. Later, you can use the ratio to find a formula for circumference. Circles do not have sides and angles, but every circle has a radius and a diameter whose lengths you can measure and compare. So, for our example 1, determine if the radius and diameter of the 2 circles are proportional. So we have a larger circle radius of 5 and a diameter of 10, smaller circle radius of 3 and a diameter of 6. So if we set up a proportion, we compare radius to radius and diameter to diameter, we get 5 over 3 is equal to 10 over 6. Well, 5 times 2 is 10, and 3 times 2 is 6, so this does look like it works out. So now, obviously, I've already put the reflection answers up here, but in every circle, what is the ratio of the radius to the diameter? Well, your radius will always be half of your diameter. Don't forget that, always. That will never change. What is the ratio of the circumference to the diameter? That's what we call pi. That's what we were talking about up here in this top section. So for the draw conclusions, based on the ratios of the radius to diameter and the circumference to diameter, are all circles proportional? Yes, every single circle will always be proportional. Is the ratio of circumference to the diameter of the circle the same for all circles? Yes, most definitely, absolutely it is, and always will be. So now I want you to pause the video and try number 4, the your turn, since we kind of cheated and I gave you the answers to 2 and 3. Alright, so on number 4, it says determine if the radius and diameter of the 2 circles are proportional. Well, didn't we just say that all circles are proportional? So yes, even though these look a little crazy and you're thinking, how can a 8-foot radius be proportional to a 9-foot diameter, it does work out. If you set the proportions up, it will work every time. Alright, so we're going to find some missing parts of a circle on this one. It says that you know that circumference divided by diameter equals pi for all circles. That's what we just did. You can use this ratio to find unknown measures. So for this one, the example says the circumference of the larger circle is approximately 94 centimeters. Use the proportion to find the approximate circumference of the smaller circle. Set up a proportion using the given information for the larger and smaller circles. So we're going to do C over D for each one. So we have 94 over 30 equals C over 15. Well, if we divide 30 by 2 to get 15, We divide 94 by 2, and we end up getting 47. So our circumference is approximately 47 centimeters. Okay, for B, it says larger circle has a circumference of 50.24 centimeters and a diameter of 16 centimeters. The circumference of a smaller circle is 25.12 centimeters. Use a proportion to find the diameter of the smaller circle. We're going to use the same setup. We're going to do C over D equals C over D. So 50.24 divided by 16 and 25.12 divided by D. So notice 2512 is half of 5024. So if I divide this one by 2, I have to divide this one by 2. So my diameter of the smaller circle is going to equal 8. So now go ahead and pause your video. You need to answer number 5, where you're going to use a proportion to find the approximate diameter of the smaller circle in the picture. So pause it, and then when you come back, you can check your answer. Alright. Cover up my guided practice. So for the year turn, when we set up our proportion, we have 44 over 14 equals 11 over x. I should have put an x there. So we know that to go from 44 to 11, we divide by 4. So then we need to divide 14 by 4, which is going to give us 3.5 meters. Alright. So if this was confusing, maybe slow it down, pause it, try to watch it again. You can always request a workshop. And good luck. Let me know if you need any help.